We have looked at the 6 trigonometric functions of acute angles in the previous section. So, in this section, we will discuss on trigonometric identities. An identity is an equation that is true for all possible replacement of the variable, and the following is the list of the basic identities. So this is called reciprocal identities, where cosecant theta is equal to 1 over sine theta, secant theta is equal to 1 over cos theta, and cotangent theta is equal to 1 over tangent theta. And this is called quotient identities, where tangent theta is equal to sine theta over cos theta, cotangent theta is equal to cos theta over sine theta. This is called even and odd identities, where if you sign negative theta, so it is equal with negative sine theta, cos negative theta is equal to cos theta, tangent negative theta is equal to negative tangent theta, cosecant negative theta is equal to negative cosecant theta, secant negative theta is equal to secant theta, cotangent negative theta is equal to negative cotangent theta. And also we have Pythagorean identities, where sine squared theta plus cosecant squared theta is equal to 1, and tangent squared theta plus 1 equal to secant squared theta, and 1 plus cotangent squared theta is equal to cosecant squared theta. By using all the identities, we can factor, simplify, and manipulate the trigonometric expression in the same way that we manipulate strictly algebraic expression. On the other hand, to verify most of the trigonometric identities, we should at least know all the identity above, and a lot of practice is the only real way to learn how to establish the identities. For example, let's say we want to multiply and simplify the given expression. We have cos x in bracket tangent x minus secant x. By looking at the identities, we can expand the equation. First, cos x multiply with tangent x minus secant x, we just multiply in the bracket. So we get cos x tangent x minus cos x secant x. And then use the identity. We know that tangent x equal to sin x over cos x, and secant x equal to 1 over cos x, where we can simplify this by cutting the cos x with cos x equal to 1, and here cos x divided with cos x equal to 1, and we simplify the equation and become sin x minus 1. So let's say we want to verify cos x over 1 plus sin x plus tangent x, which will be equal to secant x. So we write the left hand side. So cos x 1 plus sin x plus tangent x is equal to cos x 1 plus sin x. So the identity of tangent x is equal to sin x over cos x. So I want to make sure these are the same. So cos x here, I will multiply with cos x plus sin x here, multiply with 1 plus sin x. So our denominator will be the same. I'll make the denominator same. So as I want to make this denominator same, so we just multiply cos x here and 1 plus sine x at this side. So we get cos x 1 plus sine x. So as I expand, if you see this one, you can get cos squared x plus sine, multiply with sine, we get sine squared x plus sine x. So as we know that this will be equal to 1. So I will not expand the denominator. So we get cos x 1 plus sine x. So why I didn't expand? Because we can see we have a same value with the denominator, with numerator with denominator. At numerator, we get 1 plus sine x. Okay. At denominator, we get cos x 1 plus sine x. So which is 1 plus sine x over 1 plus sine x. We get this equal to 1. Therefore, we get the value of 1 over cos x. Okay. So finally, 1 over cos x is equivalent to secant x. So we already verify the function. Guidelines for establishing identity. It is suggested to choose the side, whether left or right side, containing the more complicated expression. Rewrite sums or difference or quotient as a single quotient, and then rewrite one side in terms of sine or cosine only might help. So we just need to practice and use the identities to verify the equations. Now look at this exercise. Pause your video and try to solve it by yourself. Let's say for question 1a, we want to simplify the given trigonometric expression. So A, we have cos secant x over cotangent x. So since we want to simplify this equation, so we remember cosecant x is equal to 1 over sine x, and cotangent x equal to, the identities is cos x over sine x. So as we simplify, we will get 1 over cos x, or in simplified version, this is equivalent to secant x. For B, we have sine squared x cos squared x plus cos of x. So we can take out the cos squared x, and what left is sine squared x plus cos squared x. And we know that sine x plus cos squared x equal to 1. So we get cos squared x. So this is the simplified version. For question 2, we have to verify that the equation is or this side is equal to this side. So we can choose either left or right. So let's say I choose the left side. So for A, I choose the left side, so 1 over tangent x plus tangent x. So this is equal to 1 over tangent x is equal to cos x over sin x plus tangent x is equal to sin x divided with cos x. So I want to make the denominator same. So multiply cos x with cos x. So we get cos squared x. And then multiply sin x with sin x. So we get sin squared x. So we have same denominator, which is sin x times with cos x. And we know that this part is equal to 1. So we have 1 over sin x cos x. And this is equal to 1 over sin x refer to cos secant x. 1 over cos is secant x. So we verify this equation. So you solve question 2a. For 2b, okay, so again we can choose either at the left or right side. So I choose the left side since it is more complicated. So you write again, you want to verify whether this side is equal to this side. So 2 sine squared x plus sine x minus 3 divide with 1 minus, where cos squared x here can be equal to 1 minus sine squared x minus sine x. So expanding this, we get 2 sine squared x plus sine x minus 3 over, if we simplify this, we get 1 minus 1, 0, and then plus, and then we get sine squared x minus sine x. And then we can factor this. As you see, this is actually x squared plus sine x minus 3. So as we factor this, we get 2 sine x plus 3. And then this is sine x minus 1 over. So we take out the sine x here. So we have sine x minus 1. So we can cut this and we'll get 2 sine x plus 3 over sine x, and we will get 2 plus 3 over sine x, which also equivalent to 2 plus 3 cosecant x. So the equation is verified because we can get this equation. Our main point is we want to show that this side is actually equivalent to this side.